welcome to Climate Now. I'm James Lawler. Today's episode is the second in our series on sustainable aviation fuel, or SAF. In our last episode, we explored the different pathways to developing sustainable aviation fuels and the complex logistics associated with bringing them to market at any scale. Today, I'll be speaking with one commercial producer of SAF, Montana Renewables, which is using the HEFA process, which again stands for hydroprocessed esters and fatty acids, a process that involves refining and adding hydrogen to waste oils, such as used cooking oils, tallows, soybean oils, etc. Today, the HEFA process is producing commercially available sustainable aviation fuel, but has similar logistical challenges to other SAF pathways, including obtaining feedstocks and getting final products to market. So I wanted to understand how Montana Renewables is approaching these challenges. Today, we are taking you to Great Falls, Montana, home to Montana Renewables. Montana Renewables was founded in 2021 when Calumet Specialty Products Partners purchased a century-old refinery in Great Falls for the purpose of transforming it into a refinery for making renewable fuels. Now a subsidiary of Calumet, Montana Renewables started operating in late 2022 and claims to be, today, the Western Hemisphere's largest maker of sustainable aviation fuel, producing, it says, 30 million gallons of SAF per year, with the ability to increase that output significantly over the next 2 to 3 years. The company produces even more renewable diesel, about 200 million gallons each year, as well as hydrogen. Crucial to Montana Renewables' success is its location near abundant renewable feedstocks in Montana and Canada for refining into sustainable fuels, especially crops with oily seeds such as camelina, and even the fat rendered from meatpacking plants. Montana Renewables' sustainable fuel business works with producers in the region, providing a financial boost to the farmers and others who sell their feedstocks to the company. A recent University of Montana economic analysis has determined that Montana Renewables' presence in the state has created job opportunities for 4,000 people. My guest today, Bruce Fleming, is CEO of Montana Renewables. Bruce, it's great to have you on today.
Yeah, James, pleasure.
I wonder if you could start by just telling us a little bit about your background.
Yeah, you bet. So my background is started off as a chemical engineer, actually working on alcohol to fuels conversion processes for Mobil, who commercialized one in New Zealand a long time ago. So, there's a lot of legs, a lot of history in renewables that sometimes people aren't fully aware of. So I'm harnessing some of that on behalf of Montana Renewables. We happen to be the Western Hemisphere's largest sustainable aviation fuel producer, which sounds great. That says almost nothing because the amount of SAF being produced in the world is a tiny, tiny drop in the bucket.
Just to kind of ground us in reality as we have this conversation, by my research, it looks like globally we use something between 80 and 100 billion gallons of jet fuel per year. How many gallons per year today of SAF is being produced?
So last year, the world produced maybe 200 million gallons, And if you want 80 billion, somebody with a calculator is pretty quickly going to figure out we're at 0.1% or less. We're seeking 80 billion replacement if you want to decarbonize aviation.
Bruce noted that Montana Renewables currently produces 30 million gallons of SAF per year, or 15% of the SAF produced worldwide. He said that in addition to the 30 million gallons of SAF, the Montana facility produces about 200 million gallons of renewable diesel fuel each year. Why did Calumet purchase this refinery? Why this location versus some other refinery to do what you're doing?
This was an opportunity. There was a Canadian upstream company, a crude oil producing company, which owned this small refinery in Great Falls. They decided in their business model that didn't actually make sense for them to continue, and it came up for sale, so we bought it. We've owned it about a dozen years at this point, and we saw a lot of potential in a couple of different directions. And so in two waves, and there's a third wave coming, we've put, rounding off, $500 million in twice already. We did it in 2016. We did it again in the last couple of years. We're going to do it again. It's a very, very compelling platform. And when somebody tries to find Great Falls, Montana on a map, you're going to start wondering, what did we see? And in the renewable fuels space and in the SAF space, what we saw was proximity to feedstock. Transportation costs are enormous. Feedstock access is a problem for some. And it's growing in our backyard quite literally. Second thing we saw was we are adjacent, and I mean physically adjacent, to some of the best carbon preference product markets in the world, like British Columbia, Canada.
What do you mean by that?
So what's a carbon preference market? People have heard of things like low carbon fuel standard, renewable volume obligations, blending mandates. The 4 West Coast states and provinces in North America each have their own rule requiring continual improvement on carbon reduction in the transportation sector. Continuous improvement. And it ratchets down, and it's working. California started this, British Columbia was next, Oregon and Washington. Now all of Canada has the same rule. Other U.S. states are opting in. So there's a lot going on, and it's going on fast.
Bruce was referring to mandates like California's Low Carbon Fuel Standard, or LCFS. Montana Renewable's location in Western North America is ideal, he said, since it is geographically close to Canadian provinces and to California, Minnesota, and other U.S. states that offer tax credits and other financial incentives to companies that produce or use sustainable fuels.
We had a whole lot of things going for us. We had a 100-year-old site with the trained, experienced, and qualified workforce in place. We took existing assets that we knew everything about from the standpoint of inspection or maintenance or just our stewardship.
So let's dive into what is being produced at the refinery today. What are you guys making?
So let me start with the few things that we don't talk a lot about. We make renewable hydrogen.
Mm-hmm.
We make renewable natural gas. We make renewable propane. We make renewable naphtha, which is a drop-in gasoline blending component at the moment. But that is also the source of all of the world's plastics, ultimately. So, if you want renewable plastics, the road there is going to go through renewable naphtha. We make that. Then we come to the workhorse, which is 95% of what we produce, SAF and renewable diesel. Right now, it's mostly diesel. We're developing an investment that will tilt that the other way. It'll be mostly SAF.
The raw materials or feedstocks used in the HEFA process are oil-based and can include used cooking oils, animal fats, and even oily seeds. To create the fuel, the feedstocks are heated under high pressure and temperature, along with a catalyst that hydrogenates them, removing their oxygen atoms and converting their double bonds to single bonds, which convert the feedstocks into hydrocarbons. Further processing yields hydrocarbons such as diesel and jet fuel. I asked Bruce what feedstocks Montana Renewables uses to make SAF and other products.
What is the feedstock for these things? Triglycerides. It's a mouthful, but it's a naturally occurring oily molecule. We get ours from any seed crop. We run camelina oil. We run canola oil. We have run soybean oil. It's not normally in our economic solution. And you also get it from animal products. So it is the last recycled waste material from a meatpacking plant. It's called rendered product. So it's tallows. That's a solid waste. We run that. We don't care. We can run any of these things. We're happy to run any of them. Used cooking oil is oil that was already used once, so we're going to use it again. So there's a real circular economy here. From a carbon point of view, this is directionally carbon neutral life cycle. So the modelers will quantify that, and they'll do it very carefully. They'll get into things like whether the farmer used fertilizer, and if he did, how was the fertilizer made, and did the making of the fertilizer use fossil energy? Some of our feedstocks are calculated in these detailed models at up to an 80% reduction from their fossil equivalents. It's a pretty exciting thing to be part of. And here's the kicker. We had everything going our way, like I said. We had the workforce, we had the assets that we needed. And all of these feedstocks grow in our backyard. And what I mean by that is they were all in commerce anyway. We just tapped into something that was existing, and that was mutually beneficial. Farmers get a better price from us. We get a lower price than importing these same feedstocks from far away. And when you do both of those on a short supply chain, you have cut down on the ton miles traveled over roads or over rail. Mm-hmm. So this is very, very synergistic. I like to think of it as circular. It's substantially carbon neutral. This is where the energy transition wants to head.
Talk about the logistics of this site, because as I understand, that's another critical feature. If you're going to produce SAF, you have to figure out a way to get it into blending facilities and then get it actually into airports to planes. And you got to use existing infrastructure to do those things.
At this time, all of the renewable feeds and products are moving by rail. We're fortunate in that regard. Great Falls, Montana, for historical reasons, was a rail crossroads. It's one of the major nodes on the Burlington Northern system. So we've got excellent access to a very, very large adjacent rail capability. We have a direct link into our refinery site. I think we're probably about 5 tracks wide, and we can easily turn 2 or 3 times the number of cars that we need. That's unusual. So that's another lucky accident specific to us. Most petroleum refineries are pipeline connected, not rail. Most would have to spend a lot of money replicating what we had available to us. We feel pretty good about that. The feeds tend to be gathered locally, and locally means within 500 miles. So depending on sort of scheduling efficiencies of the railroad itself, that's 1 or 2 or 3 days away. That's quite close. It gives us a lot of flexibility. Outbound product, same thing. We've had as much as 50% of our product go back to Canada. If you pull out your map of North America, Montana shares a very, very long land border with Canada, some good high-speed highway connections as well as the rail. So, there's a lot we can do with our position. That all revolves around the fact that it was the West Coast that elected to lead the way on the LCFS and carbon reduction initiatives.
Yeah.
So our natural market is exactly where we sit.
Right. Bruce, Montana Renewables has invested about $1 billion in the Great Falls facility over the past several years. What was required to convert this plant from refining fossil fuels into a plant for making lower carbon fuels?
The $500 million or so that we put in 2016 and a similar amount in the last couple of years went to a lot of different things.
Okay.
What we had to do to make RD and SAF was almost literally as simple as taking one of our existing refinery assets, changing the catalyst that it holds so that we could change the feedstock to renewable. We had to do very, very little beyond that. So that particular refinery unit, which we had earlier constructed, luckily had all of the right kind of chemical engineering attributes to be perfect for renewable feedstock. So we simply switched feedstock. Took very little money to do it. We then expanded that base. And so building the renewable hydrogen is an example. That was a discretionary decision, but had a very, very high economic driver. And we really like the renewable hydrogen nature, the fact that we have got this closed loop where the hydrogen is ultimately made from our same feedstock that comes from plants or animal waste. That's innovative. So we have a patent application out on that. It's the only one I know of in the world. And, we think that's the way everybody will do it going forward. We're not aware that anybody has done it until now.
Now, when you say renewable hydrogen, are you referring to, you're obviously not referring to green hydrogen, you're not referring to blue hydrogen, you're referring to...
The Department of Energy has asked us to stop calling hydrogen by its color. And
okay.
I think
I didn't get that memo.
Sorry. They would rather have numbers, how much CO2 is emitted or how much, cost was it to
that
make
makes
the
sense.
hydrogen. So they're just able to put everything on a common scale. So if you think about it that way, the hydrogen is produced in a water gas shift reaction that looks exactly like the way fossil hydrogen is produced from methane. So if you ever heard of a steam methane reformer, our hardware is just like that. We don't put methane in it, and we don't put any fossil in it. What we put in it is hydrocarbons that have anywhere from 1 carbon up to about 6 or so, which are coming off of our SAF and renewable diesel producer. Most process operations generate a little bit of light ends. We like to call it light ends. It means these small, short hydrocarbon chains. If you innovate correctly, you can put that into a steam methane reformer hardware and get hydrogen out of it.
And what happens to the carbon in those?
Yep, and the CO2 goes back into the biocycle so that the plants pick it back up grow the seeds that lead to our feedstock, that leads to our light ends, that lead to our hydrogen. Closed cycle.
So, right. So because it's not coming from fossil, you're not adding to the amount of CO2 in the atmosphere. You're taking it from plants.
Yeah, no, that's correct. And one more thing. So people like to talk tier 1, tier 2, tier 3 emissions. Let's do that briefly. So our renewable products are up to an 80% reduction from fossil. That's tier 3. That's when the end user of the product, puts it in their engine and burns it to perform work, whether it's a locomotive or an airplane.
And that's neat. Sorry to cut you out there, Bruce, but that's neat product you're referring to, right? So that's like when it actually goes in the plane, though, it's a 30%. 30% would be SAF and 70% would be fossil. Am I wrong about? Is that not right?
You're not wrong, but you're intersecting two things that are different. So let's make sure to name them. So thing one, I just made SAF. And that gallon, here it is. I'm handing you a gallon. That's jet fuel. You can put it into your plane.
Got it.
When you put that gallon in, you're going to take 1 gallon of fossil out to make room.
Right.
Your plane is going to use the same gallons it used before.
Right.
So I've now reduced 80% per gallon.
Mm-hmm. Mm-hmm.
Now, if somebody elects to blend and say, well, I took a 50% of this SAF and I took 50% of fossil and I blended them together, what does the blend look like? Well, it looks like whatever the blend looks like.
Mm-hmm. Right.
And the specifications actually point you to do exactly that. So when I use the word SAF, I mean the 100% pure quill energy transition fuel.
Got it. Great. So that's 80% reduction from fossil in what you're doing. So that's very interesting.
And that's where everybody's going. That's the parameter.
Mm-hmm.
The carbon intensity, you'll sometimes hear it called that. That's an excellent yardstick. The models are pretty mature at this point. CARB has been perfecting it. British Columbia has been perfecting it. Every government everywhere has looked at these. I think they work. Mm-hmm. So that is how you know how well you did on the carbon cycle.
Mm-hmm. Yeah.
And you want to see a reduction there.
Got it. One of the things I find really interesting about what you've created at the site is this ability to use a lot of different feedstocks. It seems like that's valuable in a couple of ways. Number one, that it provides some resiliency to pricing. So if you have one feedstock that's more expensive, you could use more of another to produce your product. What is the main value of having this ability to use all these feedstocks? And then what's the logistical challenge to make that possible?
Your first driver, which is the flexibility to follow market price efficiencies, is really the root consideration. The second one is right now in the world, 80% of the feedstocks that go into anybody's biodiesel or renewable diesel are alternatively food. In other words, 80% of them are variations on vegetable oils. That's going to change. The government policy and rules are clearly shaping up to try to separate food from fuel.
Bruce refers here to what's known as the food versus fuel conflict over whether farmland should be used to grow feedstock crops for biofuels rather than food crops. If farmers find that biofuel crops are more profitable, food crops could conceivably become less available.
That sets up the third driver, which is we wanted to make sure that we could run the feedstocks of the future. Nobody's quite sure what those will be, but you'll hear people mention things like camelina, jatropha, pennycress. We think we're the first, and we may be the only. We have run camelina oil. Camelina is a particularly interesting story, which I'd like to get into with you when we reach that point. But
yeah,
the feedstock flexibility was intentional because we expect these markets to evolve pretty fast. We expect rules to change. We expect economic drivers to change. So in terms of our feedstocks, one of the reasons you have people looking at a lot of alternatives to vegetable oils and animal wastes is the idea that there won't be enough of those to replace all of the crude oil. Mm-hmm. That idea is almost certainly correct in the long run.
Right.
If you want to replace all of the crude oil, there's not enough of anything. There is no named technology that will lift that challenge. Therefore, you need a little bit of everything. They all come in.
So it seems like a very good choice to, if you're setting up a HEFA facility, to be very thoughtful about some of these feedstocks of the future, as you said.
Yeah, and for our growing latitude, we like camelina. If you try to find some of these color-coded maps of where things grow, it's going to generally grow sort of along the south side of the U.S.-Canadian border. The farmers use it anyway. I mean, they're using it to hold down the soil in the winter. They use it to maintain soil quality by switch crop and pulse crop applications. But they weren't harvesting the seeds. They were using the plant for the soil, then they were plowing it back under. But the seeds now have cash value.
Yeah.
Because you can squeeze them for the oil and I will pay you for it.
Mm-hmm.
So that oil is beginning to come to market and it's specifically coming to us. What's important about that is on three levels. A, it's not food.
Mm-hmm.
So to the extent that we are ever headed for food versus fuel, we're gonna end around that potential policy concern. Number two, it's not competing for something else. I needed to switch the wheat crop to preserve the soil conditions. I'm using camelina, but I didn't have to not plant wheat. And then the winter, it likes kind of poor quality soils. It doesn't mind being arid, so it does well in the winter when it's not raining. And therefore, no indirect land use charge, if you're familiar with the modeling. And that's a big deal because it's got half the carbon intensity of the best vegetable oil.
I understand that indirect land use changes are factored in when calculating a fuel's carbon intensity. Could you explain what that means?
So let's start in the acreage. Mm-hmm. I'm going to grow a plant or an animal from which later I'm going to have a feedstock for somebody like Montana Renewables. In growing the plant, I tied up land and I performed activities. And the activities would be things like planting, plowing, harvesting. So the model tries to take into account all of these indirect energy uses. Mm-hmm. The real kicker is, what was the land doing right before that? If the land was idle and you plowed it up, you might release back into the environment things that had previously been sequestered just before you touched it. Mm-hmm. If the land was not idle but was already in another productive commercial use, in other words, I'm growing a different crop and I switched. And then the third category is if I had to clear the land in order to get to it. That's the worst one because you're actually cutting down foliage. And the disaster case is deforesting a rainforest to plant a rubber plantation or to plant palm oil trees. How you use the land, what the land was doing before, matter a great deal. This all goes into the calculations. So basically, for camelina, we're using idle land. It wasn't doing anything before because it was winter and it was going to sit there bare. And so there's not a charge for basically degrading, if you want to think of it that way. And we didn't clear any forest in order to get the land to do the planting. So, all of this is in the LCFS models. We really like camelina for this reason. Not food, super good carbon intensity leverage because of not competing for land use, and fairly prolific in terms of the amount of oil in each seed. Very high oil content, very oily seed.
So, Bruce, in your facility at Great Falls, you have a strategic plan, I guess you'd call it, that you've named your max SAF, meaning maximum sustainable aviation fuel case or production case for the plant. Could you describe what that means? What does max SAF mean for the Great Falls facility?
Sure. It probably means a couple different things, and we can unpack some of this for your listeners. But the first thing is that we've already run our treater up to 30% SAF yield. We've got it tuned for diesel. That's how we set the business up. But we do make SAF as an intentional co-product. And the current capability is economically limited around 30%. So what we've designed is by adding a second reactor and changing the catalysis around a little bit, we can take that, the licensors say, to 100%. We think economically probably more like 85%. But max SAF means we'll have the capability to take the renewable feedstocks all the way to SAF. And, that's pretty exciting. We talked earlier about our current permitted capacity of 230 million gallons. So as we install this second reactor, we've got a chance to debottleneck and expand. So we're going to take that also. We think the entire facility is going to be north of 300 million gallons. So if you put those two things together, that could be all SAF. And that's huge because the White House's SAF grand challenge is they'd like to see 3 billion gallons of SAF. I realize I'm throwing a lot of numbers here, but they'd like to see 3 billion gallons of SAF by 2030. We'll get them 10% of the way there pretty much now.
Bruce, out of curiosity, since SAF seems to have more profit potential than renewable diesel, why not pursue max SAF from the very beginning instead of going to renewable diesel first before SAF? Was that an economic choice?
It's a practical juxtaposition of several things. Mm-hmm. First off, we touched on this earlier, but we had an existing facility which took very, very little effort to switch from fossil to renewable feedstock. We're very fortunate in that regard. So the question was on the table whether we ought to jump to this expansion and max SAF from the get-go. We sequenced a number of things to get where we are. We're sequencing additional things to get the SAF yield up and to get the capacity expanded. So it's a continuous journey. In the real world, we wanted to allow the possibility for the market changing around us, wanted to allow the SAF buyers to figure out what they wanted. That was really all over the map for the last several years. It's becoming standardized now. The U.S. Passenger carriers, for example, have started to articulate a common vision of 10% SAF by 2030. They wouldn't have been as aligned a few years back, and it was, frankly, a little hard to figure out what the customer really wanted or needed. That's all become much more clear. So we feel better about having got a couple of years of learning curve under our belt in the field. We've got a very good customer and off-taker in Shell who goes onwards to the aviation industry. We like that relationship. And, we think we're simply building on those successes and expanding the beachhead.
Sustainable fuel companies like Montana Renewables have powerful financial incentives to produce fuels having low carbon intensities, or CI scores, because states with low carbon fuel standards, like California, put a cap on the carbon intensity of fuels used and give tax breaks to companies that meet those low carbon requirements. Plus, customers, including several airlines, are willing to pay a premium for low carbon sustainable aviation fuel to help them meet their emissions goals. Earlier in the conversation, Bruce alluded to the fact that the feedstocks that a company uses can have a major impact on the carbon intensity of its fuel. That's because when calculating a fuel's CI score, modelers consider its entire emissions life cycle, including the CO2 emissions that occur when the feedstock is planted, harvested, transported, and processed. As Bruce noted, the low CI scores of his feedstocks contributed to up to 80% lower CI than fossil aviation fuel.
One feed class is vegetable oils, soybean oil, canola oil, etc. And that's a large existing global industry. It's tied into food. And you've got something in the zip code of half the CI of fossil materials. But you can do better. So the next group is waste byproduct materials. And so that'll be things like corn oil from ethanol plants, tallows from the beef rendering, the waste recycling of animal protein value chain, a couple others in that class. Those are in the zip code of about a 30 CI. There's more range now. So some of ours are as low as 25, some of them are as high as 35. But now you've got, again, tremendous leverage because you've reduced the fossil equivalent by, 65 to 75%. And then you come to camelina, which we're very bullish on the future of it. It's present in the market today in very small quantities, but that's a non-food seed oil, and it's a very rich one. So you get leverage on the carbon models, the CI calculation models, a couple of ways. And then the final comment, so then we can take all of those numbers and make them better by 4 to 6 CI points because of our renewable hydrogen. We can make them better yet by working upon other site utilities. So any operating site is also going to have requirements for electrical power, steam, odd bits of other things that represent energy consumption. And as soon as you go to energy consumption, you're going the wrong way on your CI score. You're adding to it. So we've got a cogeneration facility that we're going to install as part of the MaxSAF expansion, we think that takes 14 CI points off of all of our feeds. So anybody can do these things. And over time, we think everybody is going to do these things. Once you launch a new industry, which is what the U.S. has done, we've launched a whole new industry here in the last 10 years, the HEFA processing. Then you start to make it more efficient and effective, and it just keeps getting better.
Bruce, I'm curious how Montana Renewables fits into Calumet's larger strategy. Does the company plan to continue owning and operating this facility, or perhaps instead to sell it?
Calumet is a serial entrepreneur with a 100-year history. What we like about this business is we're early. We're helping shape it. We may be the strongest competitor. We have several analyses that point to that. And that's just an accident of location. If I have the lowest shipping costs, I'm ahead of everybody else on that metric, and so on around the table. So when you think about it that way, we feel very good about our position. However, we're also a small business. And one of our publicly communicated goals is we would be open to the right kind of partnering. So if I had a complementary partner who brought something organizationally that we lack, and that might be that they had a whole lot of people and a lot of technical expertise, and we could move along this CI improvement learning curve faster with that help, that would be real value. We're interested in partnering. We're probably not interested in selling the company, but on the other hand, we're entrepreneurs, and if somebody makes us an offer we can't refuse, we have to look at that.
Bruce, have you done any studies of the economic impact of a producer like Montana Renewables in the state of Montana? Has anyone looked into that?
We have. That's very interesting from several respects. The University of Montana has an economic model. This is an independent group. The government uses this model for studies if they need to know, the interrelationship among industry and economy and tax base and whether that's good for the state. What they found was 4,000 people can live in Montana because we are here doing this. And that's a big deal in the Intermountain region. There's been slow population decline, or at best stagnation. It's hard to create opportunities. We've got a very high-tech opportunity here. Our workforce is technically trained. The pay scales are high. The benefits are good. The mission is absolutely aligned with the energy transition that people talk about a great deal. And if we can go a little further, if we can attract in this agricultural processing capability, we keep going. We build more on that.
Yeah, so thank you.
Oh, you bet. We appreciate the opportunity to tell the story and spread the word. We need a lot of people doing a lot of things to drive an energy transition better, to drive it faster. And, the more people that realize that there is something they can contribute because they heard something on your podcast and they see where they could make a difference, that's good for everybody.
That's it for today's episode. The third in our series on sustainable aviation fuel will be with Stéphane Thion, Vice President of Commercial for LanzaJet, a technology company with a focus on the alcohol-to-jet SAF production pathway. Hope you'll join us for the next conversation.